right, so then looking at our first application problem, it says Carlos hits a baseball from a tee that is 3 feet above the ground. The height h of the ball, x seconds after the ball is hit, is modeled by the function h of x is equal to negative 16x squared plus 80x plus 3. The first part of this A says graph h of x on the intervals of x values being in between 0 and 5. So we are graphing this function using the x values between 0 and 5. So basically when we were graphing before, we were finding the vertex and then just using the points, the x values above it and below it. Well, now it's giving us the x values that it wants us to use to make that parabola. So we'll still do it the exact same way. We'll make a little xy table. And we'll plug in 0 through 5 for x so that we can find the y values, which will allow us to then plot those points and graph that parabola. This. So when we are using our function, plugging in 0, that one will be pretty easy. So negative 16 times the 0 squared plus 80 times 0 plus 3 is just going to give us 3. Thank you. So that's 1 point on our graph, 0, 3. Now we'll find the next point that it wants us to find when x equals 1. So plugging in 1. And I would encourage you to be practicing putting this in your calculator, not just waiting for someone else to give you the answer. So your calculator, I would just do the 1 squared and then multiply it by negative 16. And then do plus 80 times 1 plus 3. Oh, now I know why we're laughing. What did you get? If you're not laughing, it's because you're not doing your math.
You have to say it like that.
What do you get? What's the y value when x is 1? 67. Okay. Again, too bad you weren't in on the joke, Colton, because you were too lazy to do the math. All right, plugging in number 2. Negative 16 times 2 squared plus 80 times 2 plus 3. It's not as cool as 6, 7, but. So I would do the 2 squared, which was 4, times negative 16. Very good, 99. All right, couple more here to plug in so that then we can plot these points. So now I'm plugging in 3 for x. It's also 99. Well, think about it. It's a parabola. So that ball is going to go up and then it's going to come back down. So now we're starting to see those x or those y values be those mirror images. So if you plug in 4, what do you think we should get? 67. And you can check it, but you will because, again, of those mirror images. And then the last one, if we plugged in 5, what do you think we're getting? 3. Very good. Nice. So we don't necessarily see the vertex in this graph or in the table, but we know that the vertex has to be somewhere right in here because we were going up and then all of a sudden we go back down because we were hitting that ball off the tee or whatever it was. So now when we graph this, we're just going to kind of estimate. The y-axis is numbered by tens, 10, 20, 30, 40. So none of these will be exact, so we'll just kind of estimate where they'll go. And they didn't even give us a table high enough for 99, so that's annoying. But here we go. We got 0, 3, which would be somewhere between 0 and 10. And then 167 would be up here closer to 70. Again, that 2 at 99, I'm just going to obviously make it above 80 and just kind of estimate that. And then the 3 was 99 too. 4 was at 67, and 5 was back down at 3. So again, your vertex, we don't know it, but it's going to be somewhere up here. Yikes. So when I draw that parabola, it's going to go past the 99, but then come right back down and go like that. So not a beautiful quadratic, but there you go. So now what you've done is you have graphed that quadratic along the interval of 0 to 5. Anywhere where x is 0 all the way to 5. We have what that graph would look like. The next parts will go much faster because both B and C are asking about maximums. So B says, what's the maximum height the ball reaches? And when does the ball reach that maximum height? That's up here. We don't know where that is yet. When these application questions are asking for a maximum, the maximum is what key feature of a parabola? Is the vertex. And you guys will see this like anytime I'm helping somebody with like SAT questions, there's always these questions about the maximum. That's just a real life application of the vertex. So what you're having to find is the vertex now. We're having to figure out what is this highest point of our quadratic. So we will use our formula to find the x value of that because of the axis of symmetry. So we'll do the opposite of b over 2a. So in our quadratic, our b value is 80. So we're going to do the opposite of that. So it's going to be negative 80 divided by 2 times that a value, and the a value is negative 16. So then it's negative 80 divided by negative 32, which is 2.5. Very good. So that 2.5 is the x value of our vertex. And what are the x values representing? Yeah, the time, right? So that gives us the answer then to question C, because it says, when does the ball reach its maximum height? Well, that vertex had an x value of 2.5, and that's time. So it reaches its maximum height at 2.5 seconds. And then we can figure out what that maximum height is by plugging it back in. How high was it at x is equal to 2.5? So we're doing exactly what we did with all these other graphs. Now we're just giving it some real life context. So when we plug it in, we would do the negative 16 times 2.5 squared plus 80 times 2.5 plus the 3. And that would give us the y value of that vertex. So I would do 2.5 squared times the negative 16. What? 103. Very good. So the y value of this vertex is 103. We are talking about height. So the maximum height that that ball reaches is 103 feet. That's the y value of that vertex, represents that maximum height. So again, we're just giving real life context to the vertex, to what those x and y values represent. All right, last question for number 6, letter D. What's the y-intercept of h of x, and what does it represent? So the y-intercept, yep, is 3. Not thrown, but yeah, the height of the tee, right? Which it literally already tells us that. A ball was hit from a tee that's 3 feet off the ground. So that's the starting height of the ball, right? Which is the height of the tee. So starting height of ball or height of ball on the tee, or the height of the tee. I mean, all those things are legitimately the same thing, and the correct. And the correct. And correct. Okay. Number 7 is going to be a lot quicker because we don't have to graph it. And there's only an A and a B instead of A, B, C, D, E, or A, B, C, D. All right, so let's move on to that. Number 7. A movie theater company is analyzing how ticket price affects its profit. They model the monthly profit, P of X, in hundreds of dollars by the function P of X is equal to negative 3x squared plus 84x minus 212. What ticket price will maximize the theater's monthly profit? What is the maximum monthly profit? So once again, we've been given a quadratic. It's asking us for the maximum, which means it's asking us to find the vertex. So we start off by finding the x value of the vertex, which is the opposite of b over 2a. So if our b value is 84, the opposite of that is negative 84 divided by 2 times the a value, which is negative 3. So negative 84 divided by negative 6. Very good. Gives me an x value of 14. So that is the x coordinate of that vertex. And so now I will find the y value by, like I said, doing exactly what we've done, plugging it back in. So when I plug this in, I would get negative 3 times the 14 squared plus 84 times 14 minus the 212. And what do we get for P of X when we plug that back in? 376. So this vertex tells us the maximum profit we can get based on the price of the ticket. So what ticket price is going to cause that maximum profit? $14. And what will that maximum profit be? 376. Very good. All right.